Welcome back, dear students. We are doing chapter number 7 and we are dealing with exercise 2b, isn't it? Okay, so let's take the first question for the day, that is question number 6. So basically this question is a bit new for you, and there's a chapter in your class 9 only, and the name of the chapter is simultaneous equation. Okay, now when you solve this, you get simultaneous equations out here, but you haven't done that chapter yet, isn't it? But still, what to do now? It's there in your exercise, so let's attempt doing this problem. It's not so difficult, it's going to be easy only. Okay, so let's see how to do this. Now let's consider this one. Okay, so there are two equations given to you, this one and this one. Okay, now let's try to factorize 32. Okay, now 32, when you factorize it, this is 2 to the power 5. Okay, after factorization. Now all of you know that square root resembles to the power half, isn't it? Are you understanding this? So we have 2 to the power 5 and outside we have got square root sign. Now square root sign means it is to the power half. Okay, and outside also we have got one more power, that is x. Okay, now can I write this 1 as 2 to the power 0? Yes, because anything to the power 0 is 1, right? And why only 2? I could have written any number. I could have written 4, I could have written 5 or any other number. Why I have written 2? Because all the bases are 2. Okay, so that's why I have written 2 to the power 0. It's not so difficult. Okay, now you know, whenever there is power outside, we have to multiply with the inner power, isn't it? So when you multiply half with x, it becomes x by 2. 1 into x is x, so x by 2. But here also we have one more power, so 5 into x is 5x by 2. Okay, so the power for 2 becomes 2 to the power 5x by 2 divided by, we have y plus 1. Okay, now divided by means whenever it goes up, see, divided means this can be considered as numerator and this can be considered as denominator, isn't it? Now whenever the power from denominator shifts to your numerator, it becomes negative, right? So that's why this y is written as minus y and this plus 1 is written as minus 1 out here. Now if you observe here, base is 2, here also base is 2. So that means if these two are equal, that means if the bases are equal, then the powers must be same. That is, this much is equal to 0. That's what I have written here. Okay, now let me take this one over there, so you get this much. Okay, now multiply both side by 2. So if you do that, then 2 into 2, okay, I'm sorry, 2 into 5x by 2. So here 2 and 2 gets cancelled, so only 5x will be left. Now here we have minus y, so when you multiply it by 2, you'll get minus 2y, and here we have 1, so when you multiply 1 by 2, you get 2. So you get 5x minus 2y is equals to 2. So let me call this to be equation number 1. Okay, now let me take the other case, that is this one. Okay, now we have this one, so let me shift this to right hand side, you get this much, isn't it? Now factorize 8 and 16. So when you factorize 8, you get 2 cube, and when you factorize 16, you get 2 to the power 4. Okay, and outside we have power is 4 minus x by 2. Here the power is y. Now again, you know, you have to multiply the powers, isn't it? So here it becomes 3 into y is 3y. So 4 into this entire thing is written out here. Now again, since the bases both are 2, that means the powers must be equal. That is 3y is equals to this much. Now let's multiply and open the bracket. So 4 into 4 is 16. 4 into x by 2. So 2 and 4 gets cancelled. So 2 ones are 2, 2 twos are 4, right? So 2 into x becomes 2x. Okay, so 3y is 16 minus 2x. Get this 2x out here, you get 2x plus 3y is equals to 16. Let me call this to be equation number 2. Okay, now I am going to multiply, see here carefully, I am going to multiply equation 1 by 3, that is this one by 3, this whole thing I am going to multiply by 3, and 2, that is this equation, this entire equation by 2. So if I do that, then let's see what do we get. So from equation 1 we get this much, because you are multiplying it by 3, isn't it? So 3 5s are 15, okay, minus is there, so 3 2s are 6, and here also we have 2, so 3 2s are 6, okay. So I have multiplied equation 1 by 3. Now let's see what happens if I multiply equation 2 by 2. So you get 4x, 2 2s are 4, 2 3s are 6, 6y, right, and 2 into 16 is 32. So that means you get 4x plus 6y equals to 32. Okay, now let me add them. Okay, so if I add, you see there is minus 6y, here we have got plus 6y, so they will get cancelled. So we have 15x plus 4x gives you 19x, and 6 plus 32 is 38. So bring this 19 to the denominator. So 38 divided by 19 will be 2. So that's why the value of x is 2. So we got the value of x. Now we need to get the value of y. Now in order to do that, you can take either 1 or 2, equation number 1 or equation number 2, and substitute the value of x to be 2. So here I am substituting the value of x in equation 1. Okay, so in place of this x I am going to write 2 now. Okay, so that's why instead of x I have written 2. So 5x, that is 5 into 2 minus 2y is equals to 2. So that's what is there, isn't it? Now 5 into 2 is 10. So here you have minus 2y equals to 2. Now solve it and find the value of y. It turns out to be 4. Okay, so the values for x and y are 2 and 4 respectively. Okay, so you may pause the video and note down the solution. Okay, let's have a look at this now. So here we need to show that this is equal to 1. So let's begin. So all of you know this goes to the numerator and becomes minus b, isn't it? So power becomes minus. Here also the same thing happens here, right? So a minus b, b minus c, and similarly this is c minus a. Now we know we will multiply the powers, isn't it? So it becomes a minus b into a plus b minus c. Similarly b minus c into b plus c minus a, c minus a into c plus a minus b. Okay, now what you need to do is you need to multiply each term. Okay, for example, a into a is a square, a into b is ab, right, minus b into a is minus ab, minus b into b is minus b square, minus into minus becomes plus b into c is bc. I hope this thing is clear. Okay, now similarly check with others. Okay, so multiply. Now in all the cases bases are x. So if base is the x, then what do? We add the powers, isn't it? So add the powers. So here you see that all of them will get cancelled with each other. So if all of them will get cancelled with each other, then your power will remain 0 only, isn't it? So you get x to the power 0, which is nothing but 1. Alright, so you may pause the video and note down your solution. Okay, so here we have another question which says if 5 to the power minus p is equal to 4 to the power minus q is equal to 20 to the power r, we need to show this thing. Okay, so without wasting much time, so this is given to us. So that means I am taking this entire thing to be equals to k. So if this entire thing is equals to k, then this must be equals to k, isn't it? Now here 5 to the power minus p is equals to k. I am now going to use this formula. Okay, so this is a new formula for you, but actually this formula is also part of your laws of exponents, okay, or laws of indices. Now this p can be taken to the denominator. Okay, so that's what is done here. Similarly, I can take this minus p to the denominator of this power. So how much is the power here? Actually power is 1. So this minus p goes to the denominator and becomes 5 is equals to k to the power minus 1 by p. Okay, so same thing is happening with this also. So 4 to the power minus q is equals to k, and from here also if I use the same formula, this 4 will be kept here, this minus q goes to the denominator and becomes minus 1 by q. Similarly the same happens with this as well. Okay, Now observe this carefully. Can you say 5 into 4 is 20? Yes. Now what is 5? 5 is actually k to the power minus 1 by p. Okay. 4 is k to the power minus 1 by q, and 20 is 1 k to the power 1 by r. So that's what I have done here. Okay. Now since the bases are equal, we'll add the powers. So when you add the powers, you get minus 1 by p minus 1 by q is equals to k to the power 1 by r. Here base is k, here also base is k. Now we know if the bases are equal, then the powers must be equal, right? So that's why the power here is minus 1 by p minus 1 by q, and here the power is 1 by r, isn't it? So they are equal. Now take this entire thing over there, it becomes plus, and that's what we wanted to show here, isn't it? So pause the video and note it down. So here we have another question which says if m is not equal to n, then and this happens, then show that x plus y plus 2 is equals to 0. Let's see how to do this. So this is given to us, right? Now it's pretty easy, you know, because if you treat m plus n as a, okay, if you treat this entire thing as a, then this becomes a to the power minus 1. And what is a to the power minus 1? It is 1 by a, isn't it? So that's why 1 by a means m plus n. Similarly, m to the power minus 1 is 1 by m, n to the power minus 1 is 1 by n. Now first, as per board master rule, we will simplify this. Okay, LCM is LCM of m and n in mn. Now divide this mn by m and m gets cancelled, so you have n, so n into 1 becomes n, and divide this mn by n, you get m, so m into 1 is m. Okay, so if you see here we have mn, here also we have mn, they will get cancelled with each other, so you get 1 by mn. Now take this m to the numerator and take this n to the numerator, so you get m to the power minus 1, n to the power minus 1. Now here the power m is x, here the power of m is minus 1, and this means x becomes minus 1. Here the power of n is y, and here the power of n is minus 1. This means that y will be equals to minus 1. Okay, so comparing the, this is not a coefficient, this is powers. Okay, so comparing the powers of m and n, okay, not the coefficient of x and y, it is power of m and n, we get x equals to minus 1. As I said, x is minus 1, y is minus 1. Okay, now if we got the value of x and y, we are now expected to show that this turns out to be 0. So let me take the left hand side. So this is my left hand side. What is the value of x? X is minus 1. What is the value of y? Y is also minus 1. So I have written their values. Now open up the bracket, you get minus 1 is minus 2 plus 2. So minus 2 plus 2 is always 0, isn't it? So that's what we need to show here. Okay, so you may pause the video and note down your solution. So your homeworks are given on the screen. Kindly do it and submit it to me. Thank you very much.